Okay, welcome everybody to Probability and Statistics. The problem we're doing today is we're giving a population with samples of size n equal to 25. They're selected at random. It's a normal population. We're given a mean of 100 and a standard deviation of 10, sigma and mu of x. And then what is the probability that the sample mean falls in the interval from mu of average x minus 1 minus point sigma x, which is the sample mean, or this, new, with respect to the mean. Alrighty, so what we have to do is the sample mean, we're going to call x bar, the probability that it's between these two intervals right here. But we want to turn these into an actual value of some kind. Well, we have mu of x from up here. This is equal to 100. Now, sigma x bar is equal to something a little bit different. The way to get that, the sample standard deviation, as opposed to just from the standard deviation, is to take sigma x bar is equal to sigma, all of the square root over the number of samples. So we've got the standard deviation divided by the square root of the number of samples will equal the standard deviation of the sample standard deviation. So this is equal to 10 all over square root of 25, which is going to equal 2. Alrighty then. So now we have sigma x. We can just plug this in. I'm going to actually get rid of that and go x bar, our sample standard deviation, our sample mean is greater than or equal to mu of x 100 minus 1.8 times 2, less than or equal to 100 plus 1.8 times 2. Alright, and then from this, you can go ahead and solve this down. It'll be 90, so you're looking for the probability of 96.4 less than or equal to 103.6. Okay, so we have those values, but now we have a normal standard deviation, a normal distribution. So we need to use the normal parameters in order to get this into a form where we can use the tables in the back of the book. So this will be the probability of 96.4 minus 100 over 2 is less than or equal to x bar minus mu all over sigma over square root of n less than or equal to 103.6 minus 100 over 2. Alright then. And then, if you go ahead and look at this, well, this is going to be equal to the probability of negative 1.8 less than or equal to z. This is taking these values and putting it in respect to z. 1.8, okay, which then you want to kind of put a limit on this because you don't have a very clear boundary here. Probability of z less than or equal to 1.8 minus the probability of z less than or equal to negative 1.8. Okay? So basically what you're doing is you're taking all of negative infinity, you're taking everything, well, let's create a line. If you've got 1.8 right here, 1.8, then you've got negative 1.8 right here, and you're doing less than negative 1.8, well, you've got all of infinity. You've got all of this and then all of infinity. So if you get rid of this infinity, just kill it from this one, then you can get this area in here, which is what you're going for with this probability. So that's why you have to do this subtraction right here. Alrighty, because less than this setup, this inequality right here, is kind of unclear. You can't just like take an integral or just say z less than this or whatever it is. In order to make this happen, you have to set it up like this. Or you can do the probability of z greater than negative 1.8 and minus the probability of z greater than 1.8. And you would get this area in there too. The first one is negative 1.8. Alright. So, solving this out, you've got the z equal here, so you go ahead into your tables. You find out what value of z, what the z value gives you. And you will end up with this equaling 0.9640 minus 0.0359, which is equal to 0.9281. And that's your probability of being within this range. So you go ahead, do these calculations. These both give you this number. 100 minus 3, 3.6 divided by 2 is 1.8. You change this to z, because this is basically just equal to z. This is just a placeholder for the equation that you're using. This shows what you're using on both of these. Then you go look in your tables for z, and you get these values. You add them all up or subtract them all up, and you get the probability that you need. So we're at 92.81%. And that is how you work with the sample mean.